This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and this video is meant to be an introduction to debugging for folks who are new to Unity and new to C# programming. So the purpose of this video is not to give you the most advanced or maybe necessarily the most efficient ways to debug your programs, but it will give you a set of tools you can use to find what the issue is within your code and either fix it, hopefully, or be able to ask the right questions if you're not able to fix it yourself. So to start off, if you would like to follow along with this video, feel free to download the files. I've got a sample project down in the description, and all you'll have to do from there, I've got an empty project here. I've just saved a quick scene in it, but it's an empty scene as well. And all I'm going to do is I'm going to right-click here and import package, custom package. Just navigate to wherever you downloaded that file. It's called beginner debugging. Open that up, and there's going to be 5 files in there. Import them all. And just to show you quickly what we're going to be doing here, I'm going to drag this good box maker into our scene. I'll hit play, and we'll see that all this program does is creates a series of 10 boxes. They're separated 1 unit apart each on the x-axis, and for each iteration, they're raised 1/10 of a unit on the y-axis. So now that we see what the program is supposed to do, we can delete this prefab and we'll put in the bad box maker, and we can start looking at how we're going to debug it. Tip number 1, watch the console. So with our bad box maker in place, we hit the play button and we see that nothing happens. In fact, it's kind of difficult to determine what's going wrong here because there's literally nothing changing. There's no boxes at all appearing on the screen. They're not even in the wrong place or anything. There's just nothing there. However, if you look down at the bottom left, you're going to notice a little message here. And in fact, what we can do is we can either minimize that screen, the game screen, and go over to the console, or you can even completely stop playing and it'll keep any error messages you have in here. And this is the console. And what this does is even before you put any debug information into your code, any methods into your code, Unity has some things that it will automatically alert you to. Typically, Unity is going to let you know when you're trying to access an object that's either it doesn't exist, it isn't defined, or is out of bounds in some way. So in this case here, when we look now in this message, we can see that it's saying that the variable cube prefab has not been assigned. So that's telling us that we have a variable, we have this slot for a prefab that we never actually populated. So this is actually a relatively easy fix. In this case, we just have this empty slot here. Like I say, for the cube prefab, we can just take ours and drop it in there. And that particular problem, at least, is now solved. Tip number 2, look at all the windows. So now when we hit play, we have something happen on the screen that changes, the game state changes, but clearly we don't have what we want. What it appears that we have here is just that 1 box is being made, not the 10 that we wanted. And unfortunately, this is a little bit misleading for us. Right now, we may look at this and say, well, gee, there's only 1 box. I'm clearly not iterating through all of the loops that I want to be going through to create my row of boxes. However, what's really important for us to do here is we have to look at everywhere that we can for information. Game scene is only showing us 1 box. Scene view is also only showing us 1 box here, and there are no errors in the console. However, if we go so far as to look at the hierarchy, we see that there are, in fact, 10 instances of our cube. So that is what we want. They're just, unfortunately, they all have the exact same transform position of 0, 0, 0. So now at least though we're on the right path. We know what the issue is. It's not that we're only creating 1 box, it's that they're being created in the wrong position. So this isn't really a debug that's going to fix anything for you, but it's at least going to get you on the right path to finding what the problem is. And now we're going to be ready to actually dive into our scripting and find out where the problem is in our code. Tip number 3, rubber duck debugging. So if we jump over to MonoDevelop, we can see now that we have our bad script here, and we've got the code that we've written. But what can be really helpful to do is actually to talk through your code. A lot of times you're coding on your own, and it's just kind of the idea that you have is in your head. It's just kind of a stream of consciousness. It's very ethereal. It's tough to pin down. So it can really help to have to speak it out loud. The name rubber duck debugging comes from this idea of keeping an object, traditionally a rubber duck. I personally have a rubber stegosaurus, on your desk that you can sometimes, if you get into kind of a situation like this, you can kind of talk through what you want your code to be doing. This is very similar to writing down pseudocode before you actually start coding, and it can even help to write stuff down as you're doing this. So for example, in this case, we've got our code here. We know what we want it to be doing, and so we can say something like, up here we can say, I want this to go for each iteration. And that's basically what our for loop is saying here. And then we know here we want to create a cube at position x equals I and y equals I divided by 10. And so just in doing that and just kind of talking through it and having to put everything in there, you really kind of can start understanding if you have any logical issues with your code, like maybe something that you're planning on isn't going to work in code the way that you're saying it, or that something really doesn't match up. Tip number 4, break out your code. So when you start getting a little bit more of a handle on working in C#, it can feel really good to be able to put a lot of stuff into one line of code and get a lot of stuff done with one method call, things like that. However, the challenge is, especially when you're first starting out, it can be really difficult then when there is an issue to kind of parse out what is the problem and kind of unpack the code that you have there. For example, in this case here on line 12 of our code, we have a lot going on here. In fact, we have kind of 2 nested things going on. First, we're instantiating the cube prefab, and not only we're creating the prefab itself, we're putting it into a position, and we're setting its rotation all in one line. In addition to that, our position is actually an x value, a y value, and a z value that we're all calculating right at that time too. All of this is happening in one line of code. It's really difficult for us to suddenly kind of really hone in and say, oh, well, which part of this is going wrong? So what can help is to kind of take these things apart and look at each thing individually. We'll start by just looking at this position. And we know, like I said, that we're going to have an x value, a y value, and a z value. So let's start by creating those variables. We have a float x, a float y, and a float z. And we're obviously going to need to assign these to things right now. For right now, though, we can just kind of pull out what we have here. So our x was 0, so we'll say float x equals 0. Our float y is this I divided by 10, so we'll put that in there. And lastly, our z is 0 as well. We'll put that in here. And then down in our constructor here, we can say vector 3x, y, and z. So basically right now we haven't actually changed anything we're doing, but we are breaking this out into 3 more lines so that we can see each one individually and really figure out what's going on. And now, in conjunction with what we wrote before, we can see clearly here that we're not doing what we asked. We wanted to make it x equals I, and we're saying x equals 0, so we need to change that right away. That is going to fix that issue for us, presumably. And that might even fix this. Maybe there's some issue where because we're instantiating things in the exact same position, they're kind of snapping together or something. This seems like a good point now where we can maybe look and see maybe this will work, because these other two, we're saying I divided by 10 here, this looks to make sense, and z is just going to be 0 every time. That's fine, we were never changing z. So we can now kind of take a step back and see, did this change that we made here fix what we want? So we can jump back here, stop playing our previous instance of the game, and we'll hit play again. And sort of helped. It did put our boxes in a row, but we're not getting that elevation change now. And this one's a little bit tougher to parse out, because as we can see here, we're doing what we wanted to. We're saying I divided by 10, I divided by 10. And so this is where we're going to have to use the last tool in this particular toolkit I'm setting up for you here today, which is going to be tip number 5, using Debug.log. So this is something you may have used already, and it's something that a lot of times people will warn against using too much, because it will, if you use it en masse in your game, it will slow down your game. But as a beginning programmer, and even if you just need to spot check something quickly, Debug.log is hugely helpful, because you can basically get any piece of information you need from a class, convert it to a string, and put it right in the console for you to see. So in this case here, if we look at our if you look back in our game and hit play, we see that while these are now appearing at their proper x positions, if we look at them all, their y's are all still 0. 1, 0, even if we go down to the very end of the row, still 0. So we need to kind of figure out why this is happening. And Debug.log can help us do this. Maybe there's an issue when we're passing this into the vector 3 and it's for some reason getting converted to 0 there. We can check that by just saying, before we actually pass this into this vector 3 here, let's just say Debug.log y should be, or technically y equals, and then we'll add in the value of y. And Debug.log will automatically convert this to a string for you. There's no issues there. So we can just put that in as such. And now if we go back and we hit play, actually I'm going to stop maximizing this on play because I'm going to minimize this now. We see here, nope, that y is still equaling 0 every single time. So that's not where our issue is. So let's take another step back. The next thing is maybe there's an issue that once it's being put into this float y, maybe that's where this is happening, and now it's becoming, getting set to 0 for some reason in this new float y. Maybe something about creating the new float right there is causing the issue. So let's try that, and let's check and say Debug.log equation result, and then we'll put in this I divided by 10 equation that we're using. So we'll put that in there. And you shouldn't have to worry about putting this in parentheses because this is a string. It'll do this in order of operations. It'll do this first and then add it to the string. But now we can see, oh, maybe this, we can double check. Maybe the equation is creating the right number, but then it's something about putting it into a float. We'll double check here. And so we go back to Unity, hit play again. But no, the equation result is still 0, too. So we know for certain that this, at this point we know for certain that this is our problem, is that somewhere in this I divided by 10, we're getting 0 back. And at this point, this is as far as debugging will really take you. At this point, you kind of have to know from C# that because we're dividing an integer I by an integer 10, what it does is it comes back with an integer and it basically rounds down. So when I is 1 divided by 10, that's 0.1, but it automatically rounds that down to the nearest integer, which is 0. Even when we get all the way up to 9 divided by 10, rounds down, still 0. That's why we're getting 0 every time. However, that's not the point of this. What the point of doing all this is that now we know that this right here is why there's that issue. And this is where, even if you didn't know that about C#, you could go to a forum, you could go to Reddit, you could go to Unity's forums and question system and say, hey guys, I'm dividing these two numbers and it keeps coming out as 0 for me. Can you help me? Like, why is this happening? As opposed to going in and saying, hey guys, I'm trying to make boxes and they're all appearing in the same place, which you're going to get an answer of, well, that could be 100 different things. Whereas if you ask, hey, why is this number divided by this number coming up as 0? Then someone's going to say, oh, because it's 2 ints. So, like I say, this is about, in this case, this is an exercise in getting to this point here where you now have a really focused question that you can ask versus just asking about a general thing you're trying to do. And that's going to get you a lot better, more valuable answers when you do run into these issues. And in other cases, it might just be that it becomes a simple enough problem that you can solve it. So, like I say, these are these 5 tools that are pretty basic debugging methods. Like I say, things like using Debug.log aren't always the most efficient, but for getting some spot checking and getting early results, it can be a really useful tool. And it can just kind of help in the way that you think about these problems as you go. So I hope this helps you with your game development, and I'm going to be doing some more of these debugging, a little bit more involved debugging videos in the future. But in the meantime, thanks for watching, and I'll see you next time.